So, hello everybody. Thank you for coming. Quite a lot of you, more than I expected. That's great, thank you. So, welcome to BOSH 101, a beginner's guide. My name is Khaled. I work, I'm a DevOps engineer at anynines. I've been working at anynines as a systems administrator since April 2016. I work on our automation team. I specialize in MySQL, and I'm a frequent user of BOSH.
My name is Patrick Hartz. I'm platform engineer at anynines. I'm with anynines since 2016. This was also the first time I had contact with BOSH, and in the meantime I fell in love with it.
Okay, so we are replacing colleagues who were supposed to have this talk. They fell ill, unfortunately, so we didn't have a lot of time to prepare this talk, and we apologize for that in advance. However, given that we frequently use BOSH, we are confident that we can give you a talk that gives you at least some hint, some idea of how BOSH works and how you can use it. Okay.
So at first, let's have a look on the agenda. We will talk about what BOSH is. We will hopefully answer the question which problems BOSH solves for you. Then why is BOSH your friend? We will also give you some hints for writing good manifests. And at the end, we are talking about 2 examples.
Okay, so what is BOSH? That is a very good question, right? So, in this image, you can already see quite a lot, and BOSH, we say, is a tool to manage releases and life cycles of software, basically of applications. You can use a BOSH CLI, that is a command line interface, or a BOSH tool, in order to communicate with the BOSH Director. The BOSH Director is the core piece of the BOSH environment, and
one important part is the CPI, it's the Cloud Provider Interface. In general, it translates all BOSH commands into IAAS-specific API calls. For example, when you would like to have a VM created in BOSH, it's translated, like I already mentioned, and there you can also see the VMs on the bottom of the image. And on each VM, there is an agent which in order communicates with BOSH directly.
Okay, so now we're going to go into the details of the BOSH environment, and we're going to look at different BOSH components in detail. First up is the BOSH Director. So the BOSH Director itself consists of several subcomponents. First of all, the BOSH Director itself, it is the brain of the BOSH environment, and it issues requests towards VMs. It manages the health of the VMs, and it does other things. It communicates with the BOSH Health Monitor, which is basically the application to monitor the health of all virtual machines deployed or managed by this BOSH Director. And in order to communicate with the BOSH Director, there's an API, which means you can write your own client to communicate to the BOSH Director.
The NUTS is a messaging system. The director and the agents communicate through a lightweight publish subscribe messaging system. It's called NUTS. The registry, when the director creates or updates virtual machines, all configurations are stored in the registry. So they are used for bootstrapping virtual machines. When a virtual machine is gone, the information can be taken out of the registry. And another component, the blob store, when you upload releases to the BOSH Director or stem cells, or packages are compiled, they will be stored in the blob store, so they can be reused later on. When you deploy software, the first time everything is compiled, usually. So this must not happen a second time. The director will take it out of the blob store and reuse it.
Okay, so there are a few other terms we just introduced, and we are going to explain them in detail later on. But right now we are going to continue with the CPI, or Cloud Provider Interface. So in this image you can see the CPI as a core component of the BOSH environment. The BOSH CLI, that cloud operator on top of the image, that represents obviously the human being. Human being issues a few commands, and these commands are then directed towards the BOSH Director. The BOSH Director the BOSH Director forwards some of these commands to the CPI. And the CPI then translates these commands into infrastructure-specific commands. So what exactly is this infrastructure? Well, we speak of infrastructure as a service, or IAAS. And in this image, you can see the traditional way of managing servers. On the left, you have your servers on your own premises. These are your own servers. You manage them. You have to take care of all the components. You have to make sure that the applications run, that the OS is updated, and that the network doesn't collapse and stuff like that. And compared to that, the IaaS, or infrastructure as a service, in that model you have a shared responsibility with a cloud provider. You still manage the applications, data, runtime, and other things, but now the cloud provider manages the virtual machines, the server, storage, and network. So the good thing about the CPI is that you only need a few functions in order to implement one. That means you can easily extend BOSH in order to support your own infrastructure if you needed it. You basically need functions to create and delete VMs, to create, attach, or delete storage, and a few other functions. It's not a lot of code that you have to implement in order to implement such a cloud provider interface. CPIs already exist for AWS, for Azure, Google, VMware, and other infrastructure operators. Yeah, and now?
Now the cloud configuration. When we think about to use BOSH in several environments, there is always an IaaS agnostic part, an IaaS dependent part. Previously, each deployment manifest specified IaaS and IaaS agnostic configuration, everything in a single file. So imagine you have hundreds of deployments on your BOSH director. It's very hard to maintain all those settings and sync them between the manifests. So the manifests were written independently to the IaaS. So BOSH introduced the cloud configuration. You can see it as a central point to define IaaS-specific configurations. For example, VM types, then with the size, disk types, networks, availability zones. Here you can see two different cloud configurations, and at the end, with the same names for the networks, you can see a default network on both sides. Left, it's a sample cloud configuration from AWS BOSH Director, on the right side from BOSH Lite. You can also see VM types, both has the same flavors, default, then disk types, and so on. You can easily see that it's really dependent on the cloud infrastructure you are using.
Okay, now next up is the BOSH agent. That should be a T. Okay. Yeah. So the BOSH agent is a small application that is deployed on each VM which is managed by this BOSH director. It communicates with the BOSH director, And should the BOSH director issue commands, then it will make sure that these commands are being executed. Finally, the next thing is it applies the changes by the BOSH director, as I just said, but also it asserts the health of the VM. So if the VM becomes unhealthy for some reason, if some application on the VM runs wild, then the BOSH agent will tell the BOSH director about that, and the BOSH director will then maybe, I don't know, restart the VM or delete it and recreate it entirely.
Monet. Monet is a Unix tool. It's not something owned from BOSH, and it's a central point on each virtual machine which is orchestrated with BOSH. It's responsible for starting and stopping processes. It monitors the processes, so that means when a process is going down, Monet tries to restart it. It also observes dependency graphs. That means, let's imagine you have a web server, a small web server running, and you need a small Redis in parallel, but the Redis has to be started in front of the web server. This is maintained and dealt with Monet. Since beginning of last year, BOSH introduced the BOSH Process Manager. It's called BPM. It's a wrapper around Monet and also a bit more. It isolates co-located BOSH jobs from each other and provides a runtime for existing BOSH jobs. But that's not part of this talk.
Okay, then. We've just told you or given you a very brief summarization of what BOSH does, what it consists of. And now we ask the question, so which problems does it solve for you? Well, the first one would be, the first feature that BOSH comes with is the fact that it is IAAS agnostic. Again, IAAS stands for Infrastructure as a Service, so you have your own infrastructure, or you have some infrastructure that you obtain from a cloud provider. The idea with BOSH is that you can deploy your software, you can not only deploy, but deploy and manage your software on each and every supported infrastructure layer. So whether it's Google's or whether it's your own servers, you can do and you can deploy and manage your own software on both these infrastructures, and in theory at least, there shouldn't be any kind of difference. Well, in theory. Again, already BOSH supports quite a few infrastructures. I've told you just a few minutes ago, you could write your own infrastructure layer, and the idea is that you avoid yourself to be locked into a certain cloud provider. So if you want to change, if you finally figure out that your cloud provider doesn't do it for you, you want to be able to switch to a new cloud provider and do so rather easily. If you are in the process of developing an application and you're not quite sure which of the cloud providers out there should be the best one or is the best one for you, you can deploy your software on a list of them, on all of them, and just figure out which one performs best for you. And now?
The BOSH Lifecycle Management is articulated around three main concepts: the release, the manifest, and the deployment. The stem cell as a minimum operating system in combination with the releases defined in the manifests results in a deployment.
Okay, now let's have a look at these three main concepts, the release, the manifest, and the deployment in detail. First up, the release. So a BOSH release comprises software and scripts that you want to deploy on BOSH. That's all. I'm going to show you a tree view of a BOSH release called Zookeeper. You can see there are packages, there are jobs, and there's other components. There's other source software. The idea with the release is that you can manage your source code like you would in a VCS. You can define packages, and these packages are then compiled by BOSH, and the compiled packages are compiled for this particular cloud, for this particular cloud. So for instance, if you compile your package, it must be compiled for the Google Cloud or for the AWS Cloud, and the compiled package is then stored in the blob store. So once compiled, BOSH can always reuse this package because it has the binary version of the package in its blob store. Then you have jobs. So these jobs are basically applications. These applications can be started using simple shell scripts, or you can do something else. Either way, you can. These applications are supposed to be started and stopped, and sometimes you may want to do other things before the application starts. So there's a lifecycle management for your application using the concept of a job. And then we also have properties for jobs. So you want to be able to customize your application for this particular deployment. For instance, if you want to change the number of instances, or if you want to change a particular configuration for your application, these job properties make it easy for you. So you have the job property defined in your BOSH job, but the configuration is then written to some file on the VM, and your application can read this file and finally get to work.
So now let's have a look on a deployment manifest. This is a shortened manifest of Zookeeper to make it easier to understand. My colleague also already introduced Zookeeper. See a manifest as a desired state in YAML. It defines instance groups, which results in the end in a virtual machines. An instance group is a combination of releases and jobs. A manifest also contains the properties my colleague already talked about. In this example, we didn't set any properties, and you can also define variables, which will be used for credentials and so on. Like this is a part of the later presentation.
Okay, now the third component is the deployment itself. So it's not easy to visualize the deployment, but in this screenshot you can see a deployment being created. What happens is BOSH reads the configuration for the deployment. It creates the necessary VMs using the CPI, as I just introduced to you, and then it updates these VMs. So the instance groups are the VMs, basically. The jobs are the applications. BOSH creates all the required VMs. It and then updates these VMs and installs the desired applications on these VMs. So a deployment basically is a collection of VMs, and these VMs are known as instance groups. One deployment freezes the release, freezes a particular set of releases and stem cells. So if you have version 1 of your release and version 2 of your stem cell, this deployment uses this version, version of the software and this version of the stem cell, and it will only be updated if you actually tell BOSH Director to do so. So an update of your deployment would mean, or you could update your deployment by simply redeploying your deployment. In other words, you can use almost exactly the same command to redeploy your deployment. And BOSH will tell you what kind of what changed. If there's a change in a particular property, then BOSH will show you that. If you remove or add a VM, then BOSH will show you that, and this way you can easily see what is going to happen with this deployment. What is the new desired state compared with the old desired state? Okay, now finally we ask the question, why is BOSH your friend? So BOSH helps you to orchestrate VMs, and if you've been doing, well, at least similar work to mine, I've been creating VMs manually for quite some time. It takes time, it's really cumbersome, it's error prone, and usually you forget to do something, usually forget to execute one particular step, and BOSH takes care of all of that. BOSH does so BOSH creates VMs in a predictable way, meaning you always know what's going to happen, and after a while you can also tell how long it's going to take in order to redeploy your deployment. Finally, it's easy to scale and update VMs, so you can either add or remove VMs, but you can also scale them. If you find out that your VM is constantly under pressure because there are too many requests on it, you want to add some memory on it, or maybe add some disk space on it. And with BOSH you can do that. Simply give it a new VM type, and then BOSH will redeploy this VM for you. If you have some data on your hard disk already, well, then BOSH will reattach this persistent storage to your new VM, and your application can continue where it stopped. Yeah.
So we at anynines we deliver full. Oh, that's the wrong part. VMs in sense of instance groups isolates jobs from each other. In our data service framework, we developed, we have a central database cluster. It's our A9 SPG. It's a Postgres cluster. And co-located on this Postgres cluster, we have a Logstash. The Logstash is responsible for collecting the metrics and streaming the logs to several endpoints. What happened in the past is that Logstash started to running wild. That means it consumes too many resources, and one node of the database cluster is going down. So the good thing of isolating jobs or the instances against each other is that the other nodes of the cluster were not harmed by this incident, I would say. So the rep manager was able to elect a new leader, and the cluster was still running. When we figure out such problems with BOSH, it's really easy to move such processes they can harm others to either to another instance group or give them a dedicated one.
Okay. BOSH also has the concept of, or supports the concept of a availability zone. So, an availability zone is a physically and virtually independent data center. If you've been using AWS, then you know what an availability zone is, but basically it has its own electricity supply and network connections and all this stuff in order to make computers run. So, if you have one availability zone, you might want to use several of them in order to make sure that if one experiences an outage, then the other is still available and your application will still be able to function. So if you think that's just not going to happen, well, it happened. In AWS's US East 1 region, one availability zone went down. And if at the time you had your application deployed to this one availability zone, well, your application was down as well. And the data it may have computed might have been lost, depending on what happened to the server on which your VM was running. So The idea is to have different availability zones and to deploy your applications to these availability zones in order to minimize the potential outage or the downtime that your application may experience.
In anynines, like I already said, we delivered a data service framework, and we have fully automated data services, for example, Postgres, MongoDB, MySQL, Redis, RabbitMQ, and a few others. Customers are using our data service framework, and they have hundreds of instances running, but not every application developer has the same needs for a Postgres cluster, for example. They need other plugins. Or a Redis. Some people would like to have a persistence in their Redis instance. Others, they don't need a persistence. With job properties, you can set those properties in each of the manifests. We developed kind of a templating in our framework, so it's generic, and whenever we deploy whenever we deploy fully automated service, then this is templated, and each flavor you can imagine for a database can be set it with properties.
All right. Now, what you want to be able to do is to manage your deployment manifests. Remember, the deployment manifests declares the desired state of your deployment. So what you want to be able to do is to treat your deployment manifests similarly to your code. You want to be able to control it or manage it in a version control system like Git, for instance. But for that, it would be stupid if you had some kind of security information that is stored or hard-coded in your deployment manifest. Now, think of credentials like a password or a private key that you may want to use in your deployment manifest, or you may want to store in an application running in your BOSH deployment. Well, variables make it easy to separate these security credentials from your deployment manifest. So you give it a name, just like any variable in a computer language, and then it refers to a particular data point in, for instance, in a security storage facility like CredHub, or maybe HashiCorp's Vault. So the idea is, if you don't have your passwords, your private keys stored in your deployment manifest, then you can version control your deployment manifest, and you can store your credentials in some security software. A
very nice concept of BOSH are the ops files. In general, they are able to manipulate manifests. We said you can deploy each manifest on each BOSH director, but it could happen, for example, that a manifest doesn't fit your cloud configuration. Let's go back to the Zookeeper example. In the networks, you can see that we need the default network. But on the AWS system, we deployed the Zookeeper also. There was no network default. Now I can say, okay, I will change the network name, but this doesn't work for other manifests. So there are cases where it's not that easy to manipulate cloud configs. What I did was I used a BOSH file. It's like a declarative language, and I just changed the network name to a network which is present in the cloud config. So in this case, I simply said, okay, go to the instance groups, look for the instance groups with the name Zookeeper, go to the networks and change it to dynamic. Now I was able to deploy the same manifest and the same untouched manifest on another BOSH director. But you can do a lot more with ops files. You can add another instance groups for that. You can also change the behavior of a manifest. For example, BOSH itself is deployed with BOSH. with the BOSH CLI. So, and to deploy BOSH, you can use a repository. It's called BOSH deployment. And depending on the infrastructure you would like to run the BOSH Director, you can choose several ops files, apply it to the manifest, and then you have the same manifest in the end, which is deployed on the BOSH Director.
Okay, now we're going to look at the principles of writing good manifests. Well, we've written a manifest or two in our time, and we believe there are a few basic principles in order to write good manifests. And in a good manifest, we mean one that you can use and reuse as many times as you like. So yeah, basically manifests should be IAAS agnostic in order to be reusable. You want to be able to redeploy your software that you deployed on AWS, maybe on Azure, or maybe on your own on-premises system. Either way, be as IAAS agnostic as you can in order to make your manifest as useful as it can be. We suggest strongly that if you want your application to be online and if you want to avoid loss of data, that you use at least 3 different availability zones. Again, if you're one of those people who enjoys risk, then maybe you don't want to do that. But again, if you see your application as one that should be online all the time, then at least 3 availability zones, or even more if you need them. We introduced the concepts of BOSH releases or BOSH stem cells in our talk today, and we suggest that you use remote releases or stem cells, meaning you specify a URL instead of uploading the release manually and then referencing it with its name in your BOSH manifest. That increases the reusability of your manifest greatly, because you don't have to manually upload a BOSH a BOSH release or a BOSH stem cell. And again, we strongly suggest that you use CredHub or Vault or some other secure storage facility in order to store your credentials. If you don't do that, you will run into problems. You don't want to keep your manifest on your own laptop or your own computer. You want to be able to share it and have someone else reuse it. But for that, you have to use some credential management that makes sense. Okay, now we're going to look at examples.
So we are on the CF Summit here, and while we are talking about BOSH, that's quite easy. BOSH is the underlying technology under Cloud Foundry, and it's used in most of the cases to deploy Cloud Foundry itself. Also, a new project. No, that's not true. It's not a new project. It's 1.5 years old, I think. It's the Cloud Foundry Container Runtime, CFCR so-called. It's a BOSH release that offers a uniform way to instantiate, deploy, and manage highly available Kubernetes clusters on a cloud platform using BOSH.
Okay, now we are going to briefly discuss how to deploy Cloud Foundry on BOSH. The steps that you have to take are very similar to deployment of any kind of BOSH deployment, but it makes sense to look at Cloud Foundry on the Cloud Foundry Summit, right? So first, you want your applications to be able to receive traffic, and we suggest that you use a load balancer to do so. So the load balancer will only route traffic to healthy instances, and if one of those instances goes down for whatever reason, then the load balancer won't forward traffic to it, and maybe in the background another instance can be spun up. Either way, a load balancer is a good idea. You simply upload a cloud config. The cloud config is available in the CF deployment repo. And then you upload a stem cell of your choice. In theory, each and every stem cell should work. We've been working with Linux stem cells, so I'm not certain whether it works with Windows stem cells, but yeah. In theory, each stem cell should work. And finally, you actually deploy Cloud Foundry. We suggest that you use CF deployment to do so. And we won't go through the actual steps because it's out of scope for this BOSH 101 talk. But you can expect the deployment to take some time, maybe between 45 and 90 minutes, because quite a lot of stuff is going to be deployed. Yeah. Hopefully, after that, step 5, you are happy because you have a running and productive Cloud Foundry deployment on BOSH. You can also have a look at Bubble, which is a very interesting project. It may help you to make the whole thing more streamlined and more easy. And after listening to this talk as carefully as you did, we can't imagine that you have questions, but if you do, now would be the time to ask them. And thank you.
So, muss ein bisschen näher kommen zu mir.
Okay, just a short question. I was to this bug talk earlier, and what's the difference between bug and bubble? Is there a difference?
There is a difference, but I can't tell you which difference there is. I never used bug.
But it's a tool that achieves this kind of the same thing?
Sorry, it includes UAA, concourse, and some other thing.
Yeah, CredHub. It's
exactly.
Therefore, the name.
Deploying that set of tools.
BUCC.
And BBL is just for easy setting up Cloud Foundry with BOSH. Yeah.
BOSH is a part of but simplifies all the steps. And the way it was the reason why it was so fast before is because that was the deployed on containers and not rolled out to VMs directly. That example that we had in the framework so far. But yeah, this is like the deep dive into BOSH, which wasn't explained during the talk because it couldn't cover it in that time. But BOSH is like one artifact in that BOSH is one artifact in that BUCC or blockchain. Does it make it somewhat clear? Still don't know what the bubble is. Yeah. Okay, can you say something about bubble?
Go ahead.
Das ist, du kannst dich besser aus.
Okay. Bubble, okay. Maybe
Can you give the microphone back?
So, I've been using Bubble only on a few occasions, but the idea is that you do the whole setting up of BOSH itself. We haven't shown how to set up BOSH itself, right? We believe that would be out of scope of this talk because it's a BOSH 101 talk, and we wanted to motivate the idea that you actually get to use BOSH, right? And we wanted to show you what the benefit of using BOSH would be, but we didn't set up BOSH itself. We set up BOSH directors and BOSH environments all the time, and Bubble helps you to do this quite a lot quicker than you would using the instructions that I'm aware of anyway. So basically, it's an automation tool for deploying BOSH. Deploying. Well, BOSH, the BOSH Director and all its components. There are other components which we didn't show today, but yeah, we call it, or in BOSH speak, it would be a BOSH environment, right? Including one particular director with all the components that are required for the BOSH environment. Does it answer your question? Okay. More questions? Please.
I have a question about using operator files. So when you do a BOSH deploy command, you specify your manifest file, and then you can specify multiple operator files.
Yep.
So using one, that's clear. You just do a sort of patch on your manifest. But if you use multiple, is there a certain order in which the operator files are applied? And can you actually put them on top of each other? Like you just run the first operator file which modifies the manifest, and then the second operator file comes in. Can you modify what you just modified, like a recursion?
Yeah. My experience is the last operation files wins. So that means when you change the same setting in an operation file before, the last is the one who's making the change.
But does it undo the previous one, or does it just ignore earlier operator files?
I think every file is applied in the order you added to your manifest. So it's an ongoing process.
Thanks.
More questions, or if not, then. Either way, then thank you, and use BOSH. Right? Bye.